Hi, my name is McLean Friend, and I am in Biomed 380A1, the online version of the Additive Manufacturing one credit class at Colorado State University. And for my project, I created the lumbar spine model. For my model, I had all 5 vertebrae, as well as the 4 intervertebral discs and the spinal cord. The vertebrae, I found a version of these files online at a GrabCAD site and modified them slightly with Mesh Mixer, but left the general shape all the same. Um, and I printed the vertebrae themselves out of PLA. I tried multiple materials, including ABS and Chromostrand, but I chose PLA because of its price as well as its ability to not warp and have a pretty accurate print for what I was doing. For the intervertebral discs and the spinal cord, I created them from scratch, and I'll show you how I did that in a minute. And I used NinjaFlex's TPU, which is a pretty flexible material because I wanted it to articulate, the model to articulate like a normal spine would. So on the right, you have L1 at the top all the way down to L5 at the bottom. So my objectives for this project were to create a functional model for the spine for a couple of different uses that I'll talk about that is individualized, strong, and relatively cheap. The final cost I calculated to be right around like $15 if you didn't mess up any of the vertebrae. It could be even cheaper if you made the fill smaller. So the uses that I could think of, a few of the uses that I could think of for this project were using it as a surgical model for spinal fusion, which could be individualized as I talked about using CT scans and then creating that into an STL file, or using it as an educational model. So for the spinal fusion model, usually people need spinal fusion because of a herniated disc, which is this middle picture here, because the intervertebral disc is pushing against your spinal cord, causing nerve pain as well as potential nerve damage. So what they'll do to fix that is they will fuse the 2 vertebrae and makes it so those two don't articulate, and so they will often take out that disc, and so there's no pressure against the spinal cord. One of the reasons why I made this model is because the surgery for that is pretty complex and is pretty difficult and many hours long. And so this would be a good way for practice surgeons or people who are trying to be surgeons to get the feel of a spine model and how they would actually go about fusing these 2 vertebrae together, as well as surgeons right before they go into surgery looking at an individual's exact model and saying, all right, this is exactly where I'm going to put the screws, and this is where I'm going to put the plates, and they'll have a much higher success rate from my understanding. For the educational model, I thought this would be really handy to have in a classroom where you're trying to teach anatomy of the spine. So each of these discs, as well as each of these vertebrae and the spinal cord, are very unique and have very unique features. And it's kind of hard to see that in just pictures, so it'd be really handy to have physical models to mess with and feel and say, oh, there's a huge difference in the model of lumbar 1 versus lumbar 5, which there is, as well as intervertebral discs, which again I'll talk about here in a second. But you could even have them as separate pieces rather than fusing them all together. And the spinal cord I left loose in my model, so you could take it out and put it back in and have different amounts of fill density on that spinal cord, so you can feel the stiffness of potentially what it might feel like. So a few things that I was very proud of on this model was the detail of the model. So I went through a lot of different iterations on trying to figure out which orientation was best to print the vertebrae. I started out by printing horizontal, and I'll show you the errors that came due to that. And then I moved to kind of a diagonal print, which still had the same errors of that the bottom part of the vertebrae was printing first and had to support the rest of it, and it was just coming out uneven and not very clean. And that was the part that I cared about the most, because that's where the connection between the vertebrae happens. And so on the right, you can see the outcome of each individual articulation of the spine, of the vertebrae, is very present in this model. Another thing that I just talked about briefly was the connection between the intervertebral discs and the actual vertebrae themselves. The way I created the intervertebral discs is actually would cut the bottom of the intervertebral disc of the vertebrae on the top, invert it, do the same thing on the bottom, and invert it. And then I did some research to figure out how thick I should make each of the intervertebral discs. Most of them are right around a centimeter thick, but they vary in length around the whole diameter of the intervertebral disc. So I would just connect them with lines to make it so it actually emulate what the intervertebral disc connection feels like. And so when I was putting it together, I could even put all of the intervertebral discs out on the table, and I could tell you which one is which because of their individual shape and how they meshed perfectly with the top and bottom vertebrae. So a few of the errors that I ran across, some of them are printer errors, some of them are my errors. The first ones on the left here where I would blame myself mainly for is the printing orientation. So you can see the printer drawing a whole bunch of different lines before it finally figures out the exact model as it goes up. Because I printed this from, on this angle, the kind of top right to bottom left. So top right was the first thing to print, and it just kind of spewed everywhere and then figured itself out. So that's why I tried to move to the more vertical print. And the second mess up that I had on the Lulzbot Mini was just kind of like a lateral shift in the print. And this I'm going to blame on the printer. I was talking to the staff in the lab. They were saying this could be due to loose pulleys. They said that since these printers have so much printing that goes through them, so many users, that it's hard to keep all of the components of each printer perfectly intact and in perfect shape. So then I moved over to the Taz because I found and heard, and so then found out myself that they had the best success rate and were much more accurate. So I tried printing them vertically, and my first one I printed on the Taz printed perfectly, and that's the current L1 that I used in my model. And this was L2 that I was trying to print, and I don't understand why, but it had more of a rotational dislocation. And this is just kind of something I learned about 3D printing is 3D printing is not always going to be exact. The better printer you have and the better care you take of it, it's going to be more exact, but even so, you're still going to have random errors. So a few more errors that I found when I was trying to use the Flexi extruder to print my TPU was it stopped extruding. So it would do the print about 30 to 40%, and then in the middle of it, it would just stop extruding, or so you can see on the far left model, it just kind of extruded everywhere and not in the actual pattern that it was supposed to. This was due to a number of things. The nozzle itself, I was told, was slightly broken, as well as the tube that the filament was fed through had been worn down through a lot of use. So they replaced both of those. And then I had 3 perfect prints, and before the last one, I had these 2 unknown errors that neither me or the staff could figure out. The printer just was going and then stopped extruding again, though it had them in very perfect. The beginning of the print was very right on. So as far as some lessons that I learned, as I said earlier, the orientation of the print, having the most detailed things that you want being farther away from the bed so they're not supporting other things, I found really important, as well as the type of printer and how well you take care of the printer. I found that in our lab, the Taz printers were the most accurate compared to the minis. As well, I found that the more support I ended up using an angle of 45 degrees for support to be the best because none of the layers of print had overlaying hanging onto nothing. So they all had support, and it helped a lot. Whereas I tried doing 30 degrees, and it just became a hassle to get all the support material off. So 45 was the optimal degree angle. I also realized that patience is key when you're trying to 3D print. You can't just go in and immediately expect the print to work. You have to kind of figure out the kinks as you're learning how to 3D print, and then it can become a lot faster after that. So changes I would make for next time would be to print all the vertebrae vertically as well as on the Taz's, excuse me. I would also make my reservations for those Taz's early because they fill up pretty quick. And I'm thinking about buying my own printer and making all of my next models on that so I can take care of it really well. And that's it. Thanks so much.